Yeah, I'm ready. Okay, yeah. Welcome, everyone. So today I'm going to talk a bit about what is ACENET and the Digital Research Alliance and what used to be Compute Canada. I'm Oliver Stuker. As Grace said, I'm located at Memorial University and I'm working with ACENET since 2015, and so does Chris Giroux, but he's located out of Halifax. What is ACENET? ACENET is an organization, a consortium that provides researchers access to advanced research computing resources from their laptop or office computers. And we offer expertise, support, and training for these resources. All these resources are free of charge for academic researchers and industry academic collaborations, and the funding is provided by federal and provincial governments and some member institutions, usually there as in-kind contributions. And ACENET is the regional partner for Atlantic Canada of the Digital Research Alliance of Canada. Now, what are the consortium partners? Those are these fine institutions here, you see Memorial University, Dalhousie University, and a lot of others. And at most of these universities, we have a few staff that are local to you and that you can talk to, especially when you're at one of the larger institutions listed here. What is the Digital Research Alliance? For that, I need to go a bit back to what is ACENET. And regional organizations similar to ACENET have existed across Canada since 2006, where basically universities came together and pooled their know-how and pooled their resources for high-performance computing applications and hardware. And from 2010 till April 2022 this year, these regional organizations have partnered together under the national umbrella of Compute Canada. Just a month and a half ago, on April 1st, Compute Canada was replaced by the Digital Research Alliance of Canada, which has an expanded mandate that also includes research data management and research software. And under this national umbrella organization, ACENET is the Alliance's regional partner in Atlantic Canada. And there are other regional organizations. There is Calcul Quebec, there is Compute Ontario with its subsidiaries, and out in the West till April 1st, we had WestGrid, but that has split into a Prairies and a British Columbia DRI institution, and I think they are still deciding on the names going forward. What's the Alliance's role in that? Basically, the Alliance tries to help allocate the funding and make sure that the funding is spent more efficiently. And also we want to provide researchers with seamless access to infrastructure and resources nationally. So that means if you are here in Atlantic Canada, you are not restricted to just resources that are present here in Atlantic Canada, but all researchers all over Canada have access to the same resources wherever the resources are available. Support will be primarily provided locally from ACENET for you here, but as you will see, we also collaborate with our colleagues across the country. And basically what's really important is that this national umbrella organization helps us to have a single strong voice to advocate for federal money and so that we can get the best deal for all the users in all of Canada. How can ACENET help? One big thing I mentioned a few times is access to resources. So our bread and butter is high performance computing, but also big data and GPU computing. You can get access to the cloud. What that is, I'm going to explain a bit later. With us, you can get access to Globus, which is a high-speed, secure data transfer service that's really good on for shifting large amounts of data, terabytes of data between different systems and even your lab computer. We have storage, which is backed up on tape, so you don't need to worry about that so much. Then the next big focus is on expertise. Me and my colleagues like Chris, like Ross and Sergey that you will meet tomorrow, and others, we can help you to determine which resources you actually need. We sometimes work with researchers to optimize their code and troubleshoot any problems when compiling their code, when getting their code running, or it has some errors in there. We sometimes do even in-depth collaboration. And even more importantly, we have specialists in all sorts of different specialities. Chris here is ACENET's specialist for big data and cloud. I'm the team lead for the National Molecular Modeling and Simulation team, and I'm an expert in molecular dynamics. Within the Alliance, we have a whole subgroup that are experts in research data management. And if you need help with that, come talk to us, and we can set up a meeting with those people. From next month on, ACENET will again have a research consultant for humanities and social sciences, which are disciplines that are not very typical users of these high-performance computing resources. There are also national teams for bioinformatics, for visualization, and high-energy physics, particle physics. So if you need help in those kind of things, I can or we can put you in contact with those people. And then as the last thing, we offer lots of trainings like this ACENET Basic series here. So group training, individual training from novice to advanced. We have standard training offerings that we offer every year, like the ACENET Basics that we offer 3 times per year, the ACENET Parallel Computing School that we run every year. You should also look out for our software carpentry and data carpentry workshops, especially if you want to learn coding in R or Python, or want to learn version control with Git. There we have things regularly scheduled. And yeah, training for research data management, the Alliance is just really ramping up on those things. I can really highly recommend that you sign up for the ACENET newsletter. If you sign up for an ACENET account, you're automatically signed up for the ACENET newsletter, unless you refuse and unsubscribe from the newsletter. But the newsletter is really where we would advertise all the training that's coming up. And we have also a website here, acenet.ca/training, where we list all the different standard trainings that we offer. And there you can, by the way, also find slides and recordings to many things, like recordings for the ACENET Basics and slides for everything else. So go and check that out. And if you want some specialized training, we have a form that you can also submit service requests. And if we see there is a good demand for that, then we will schedule training for that. And yeah, you have seen Grace, you have heard Grace, she's our training coordinator, and she manages all of these things. And research consultants like me and or Chris, we just need to show up teaching. What is advanced research computing? So there are lots of buzzwords like cloud, supercomputing, big data, parallel computing, yada, yada, yada. But basically all of these can be subscribed with a tagline: anything that's too complex or takes too long to do it on an off-the-shelf desktop or laptop. Basically, and for high performance computing, the key element is many CPUs, many processors working on the same problem at the same time. And that can have several different ways of doing that. For example, you can, if you have hundreds of data sets that need to be processed on your laptop or your desktop in the office, you can do one at a time or maybe two at a time. But you could run on our resources, you can run dozens or hundreds of jobs at the same time, and therefore analyzing your data would finish 100 times faster because you just run many simple jobs at the same time. Or you may want to run simulations where many compute cores work in sync and highly coordinated, and their communication between the CPUs is the absolute key. The advantages for you get faster results, or you can solve more complex problems that are just simply too big for a single computer to work on. And the principal tool for that is the computer cluster, or the supercomputer, how it's also called. So this is how a supercomputer looks like. I believe this photo was taken of Cedar in British Columbia, close to Vancouver. And basically, I hope you can see my mouse pointer. Each of those units here which has something blue and something yellow, that's a single computer. Those computers are actually not that much different from a desktop that you might have in your office. Well, other than the fact that it has maybe 500 gigabyte of RAM and somewhere between 32 to 64 CPUs and processors in there. But other than that, it's not that much different from a regular computer that you might be used to using on. But the key is that they are all connected with these network cables here to special networking hardware. If you're into that, there is a very fun video of Linus Tech Tips, who visited the Cedar data center back in 2017. The YouTube link is down here. So if you're interested in that, just check that out. It's a fun video. We have 4 of those general purpose computing clusters: Beluga, Cedar, Graham, and Narwhal. Narwhal and Beluga are located in the same data center, actually, in Montreal. Cedar is in Burnaby, BC, close to Vancouver, and Graham is in Waterloo, Ontario. Together, they have 265,000 CPU cores, about 1,300 terabyte of RAM. That's 1.3 petabyte of memory. 100 petabytes of disk storage, 3,200 GPUs, general purpose processing units or graphical processing units, plus a tape, which we call nearline storage for offline storage of data, and a huge software catalog that's available on all of these 4 systems. But don't get too excited. You're not going to be able to use all of these resources for yourself. Those are shared resources. And I've checked a few days ago, we had about 21,000 user accounts active. About a quarter of them are PIs, principal investigators, so your professors, who may, most of them don't actually use the clusters themselves, but 3/4 are all the grad students, postdocs, and collaborators that actually use the system. But we also have many professors that are very hands-on and run simulations themselves. So it's hard to tell who is using and who is not. Now, what's a cluster? I showed you the picture of these racks full of machines, and yeah, basically those are just hundreds or more than 1,000 individual computers, and we are not very creative with giving them names, but we just give them numbers. Each of those computers here is what we call a compute node. All of those compute nodes are connected with network. Those were these big cables that you were seeing coming out in the back. Also attached to that network are special nodes, which we call logger nodes or head nodes. Each cluster has one or a small number of these login nodes. And these login nodes are the only ones which are directly connected to the internet. And those are the ones that when you log on to the cluster, you log on to the login node. But you don't want to run your jobs, your calculations, your simulations on the login node itself, but you want your jobs to run on the compute nodes. In the back of that, we have a storage also attached to the same network. And we have 3 kinds of storage. We have the home directories for every user, the project directories for every research group, and the Scratch directories for just temporary data. This storage is mounted on all of those nodes, on the login nodes and on the compute nodes. And therefore, it doesn't really matter on which compute node your job will eventually run, because the data is there, because the data is on the storage. Your input data is on the storage, and it writes the output data on the storage. The software catalog is on the same storage. Therefore, the same software, the same data is available on all of the compute nodes. Now you may want to run your job on compute node 4. Now, how do you decide on which compute node you want to run your job? Back when I was a grad student, in my lab, we had basically 4 or 5 computers to run simulations. And when I wanted to run my simulation, I would ask my colleague that was sitting with me in the office, hey, I want to run on computer 2 and 3 today. Which computers are you running on? That doesn't scale with 20,000 users and thousands of compute nodes. So we need some authority that has an eye on what is running on which machine. And this is what we call the dynamic resource manager. Because that word is quite a mouthful, we usually call it the scheduler. And in the Alliance, all of our clusters use the software Slurm as the scheduler. And that's basically just a program that knows what resources are available, with how many CPUs, how many processors are in each compute node, how much memory is in each compute node, and what jobs are already running and which jobs are waiting to run. How to talk to the scheduler and how to submit your jobs, that will be the topic of Friday's session that Chris will be teaching. And there you hear all about the kinds of resources that you can request and how to do that. Basically, the take-home message for today is don't run your jobs on the login nodes, but submit your jobs to the scheduler that they run, that the scheduler starts them on the next available compute node. It's okay to edit some files or to compile some software on the compute node or do some very simple lightweight analysis there, but anything that's heavy lifting and that you couldn't do within 10 minutes on your laptop, that should go on one of the compute nodes. Enough of that. We also have some special purpose systems. One system is Niagara, which is a special system for large parallel jobs, where you can have really big simulations running on thousands of cores, of thousands of processors. Niagara has about 80,000 processors in that one data center, and about once or twice per year they announce Niagara at scale, where you can really run a job for a few hours on the whole system or half of the system, and there you can run really big simulations on those machines. And we also have Arbutus, which is our cloud resource, and that's often used for some persistent web services like portals. So what exactly is cloud computing? It's basically using someone else's computer as if it was your own. So with the Alliance, that means you have administrative privileges on some virtual computers where you can install the software that you want, you add user accounts and customize many things there. But you are also responsible for managing many of these things yourself, and making sure that everything is configured securely. Otherwise, your computer might get hacked very quickly, and we need to shut it down. We can assist you with that, but only so much. But a lot of the heavy lifting will be on you. But these cloud computing are very good if you want to run a web server, a website, or a portal, or like a database, or for bursts of special on-demand computing. For training, actually, we set up virtual clusters on the cloud, and that you will be working with tomorrow and Thursday. There you will actually work on a cluster that Chris will boot up just for this training there. And certain groups like the those high energy physics that work with the Atlas detector in the CERN Large Hadron Collider, they need to control every little library, and that would be very difficult to do on our high performance computing systems, and so they use the cloud a lot. So there are many different uses for that. And basically, you spin up what we call a virtual machine. And if you see, you have an actual physical computer with a hard disk and memory and a number of CPUs. And on that physical machine, you have several virtual machines that each are running their own operating system, and each are basically simulated computers that use a subset of the resources that the parent system are providing. And here, in this case, the VM2 uses twice as many CPUs as VM0 and 1, and uses more memory and more hard disk. And that's very useful basically for web servers, because web servers only work 10% of the time. 90% of the time they are idle. And so we can basically put 10 times more virtual computers on the physical hardware, because on average, only 10% of these machines will be under load at any given point anyway. So we can run 320 CPUs worth of computers on a 32 CPU machine, and that's really useful. Yeah, but for most people, I think high-performance computing systems, the clusters, is the right thing, unless you really have a special use case for cloud computing. And if you think you have a use case for cloud computing, come talk to us, talk to me or to Chris, and we will figure out whether you really need the cloud, or whether you might be better off on an HPC system where all the software is already installed for you. Talking about software, on our managed HPC clusters, we have a huge software stack that we manage, where we have every software you can imagine that any researcher in Canada has requested so far. Chances are it's already there in multiple versions already there. If we have a list here at docs.computecanada/available software that you can browse. It's really very long. Use the search function of your browser, like Control F, and then put some keyword to find that. And if there is something that you want to use and you can't find, then just send us an email, and we can point it out. Maybe it's already there. Otherwise, we will make efforts to install it to the system. Of things like a very small selection of what's already there, like in the chemistry and molecular sciences, we have Gaussian games, GROMACS, VASP, NMD, and WChem. We have machine learning tools like TensorFlow, Torch, scikit-learn, engineering tools. OpenFOAM is open source, but also commercial packages like ANSYS with Fluency of X or StarCCM from Siemens, Earth and Ocean Science software, bioinformatics, and so many things that I can't even mention here. For certain commercial packages, we expect that users bring their own licenses. So this is why there's an asterisk here at many of the packages. However, for Gaussian, we have a license that's for academic use. We have the whole data science languages. So Python, R, we have MATLAB, and actually the open source version of MATLAB, which is Octave. MATLAB you can actually use on some of our clusters. We have licenses. On others, you need to bring your own license or your institution's license. We have visualization software like ParaView, Visit, VMD, VTK. And again, if there's anything that you don't find here on that list or on the available software list, send us an email and we see and we can try to install it. We have programming languages, any programming language that you can imagine. The typical candidates: C, C++, Fortran, Java, Julia, Chapel, Ruby, different compiler suites, GCC, Intel, PGI, or NVIDIA HPC, how it's now called, CUDA for NVIDIA graphics cards, parallel libraries for OpenMPI, OpenMP, Spark, mathematical libraries, what have you, and all sorts of tools, debuggers, and yeah, as I say, most of the things that you will ever need is already there, and otherwise we can install that or newer versions of those. The Intel compiler suite is the default on our systems. The GNU compiler suites, GCC, have come a long way, and there are also many software we now only compile with the GCC software, and we have multiple versions there. And NVIDIA HPC SDK is formerly known as the Portland Group compiler, PGI compiler. It's all there in different modules. So because we have so many different versions of compilers of softwares, you need to use modules to activate that particular version that you want to use on our system. I really highly recommend looking at this page here using modules, and I'm not sure whether it's Ross or Sergey who will be teaching tomorrow's session. I think they will demo that also tomorrow. Yeah, how to get an account. If you are a principal investigator, so a professor or a librarian at any post-secondary institution, you can register an account for yourself. Just go to ccdb.computecanada.ca and click on register. And I just want to quickly point out, yes, technically we are already under the Digital Research Alliance, but you will see the name of Compute Canada pop up in lots of places, and over the next year or so, we will slowly transition to new names there and new websites. But we will make every effort that the old ones will remain for the foreseeable future. So after a principal investigator has gotten their own account, they can then start sponsoring accounts for their grad students, for their postdocs, for their external collaborators who may not be eligible to get an account for themselves. We don't allow that people just give their password to someone else. Anyone who needs to use our system can get a sponsored account somehow, but please don't give your password to anyone else. And even we as staff will never ask you for your password. We have other ways to access your account if needed. And yeah, just for registering, just go to ccdb.computecanada.ca and click on register and just follow along there. A bit earlier, I mentioned Globus for data transfer. That's a very useful service. you can go to app.globus.org or globus.computecanada.ca, and then you will get a login screen that looks like, why isn't it? Yeah, that looks like this here. And there you need to click in here. And if you type Canada, then you will see Compute Canada going on, and then you can continue, and then it will ask you to log in with your Compute Canada username and password. And eventually you will get some sort of a file manager here. And then you can use that to move data between the different clusters, say between Graham and Cedar. But if you install Globus Connect Personal on your laptop or on your office machine, then you can also activate a so-called endpoint on that machine and use that to upload or download data sets from your local machine to one of the clusters. And that's really fast and secure and fire and forget. It really makes it very easy to use. And if you let that Globus Connect Personal running on your office machine, you can even transfer data from the cluster to your office machine, even while you're at home and working with your laptop. That's a really useful service. And actually some data sets, like certain genetic data sets from the European Bioinformatics Institute, they also make their data sets available via Globus, and you can transfer data with that as well. For the session tomorrow and Thursday, you need to install some software on your system. If you're on Windows, I recommend you install a software called MoberXterm. Just go here to this URL, moberxterm.mobertech.net, and download and install the installer version. And this is to get a terminal software that you can access the cluster and the training cluster. And for data transfer, you can use MoberXterm. It has SFTP built in, but I find it also very useful on Windows to use WinSCP, and that WinSCP or the SFTP client in MoberXterm you can use instead of or in addition to the Globus Connect Personal. On macOS, for accessing the system, you only need to open a terminal where you get a bash command line. Just under applications and applications and tools, I believe, search for the terminal. You can use the Spotlight Finder for that. But for graphical data transfer, we found that CyberDuck is a very good one for graphically uploading and downloading data. But as I said, you can also use a Globus. And under Linux, if you're using Linux on your system, you're all set. You're probably a command line junkie like I am, and you don't need to install anything. You just need to be able to open a terminal and then use the terminal to upload, download data. Yeah, that's about it for me. Where to go to for help? Look at our technical documentation wikis from the Alliance, still under docs.computecanada.ca, or the ACENET wiki, wiki.acenet.ca. You can contact us anytime at support.computecanada.ca or support@ace-net.ca. when you contact us, please supply as much information as possible. What's your username? Which system are you using? We don't know that you're using Graham or Narwhal. You could be using any of the system. Tell us which software and exactly which version you are using, which modules you have used. Tell us job IDs. And if there's any error message, don't say, oh, it doesn't work. Please copy and paste the error message from the terminal into the email. Please no screenshots, but you can usually select the text and then copy the text and paste the text into your into the email client with on macOS with Command C, Command V. Otherwise, Control Insert and Shift Insert works on Windows and Linux. And yeah, we have lots of information on our technical support wiki. And yeah, that's about it. And after Grace has stopped the recording, I'm open for questions.